Okay, so today our group will be presenting on functions and graph. Our group members are Liu Zili, Sim Fui Sin, Yu Lian, and Jessica Ang. The program code is FSPA and the course code is FSPH0014. So our lesson outline is introducing the concept of a function, exploring quadratic functions, and engaging with real-world maths applications. Okay, so what is a function? In mathematics, a function is a relationship between two sets of values, which are domain and range. Function relates an element x to an element fx, also known as y, in another set. The set of values of x is known as domain of the function, while the set of values of fx, also known as y, generated is known as the range of the function.
Now I want to talk about why do we use function. First, we use function to modeling relationship. Function allow us to model relationship between variables. For example, we can use a function to describe how the value of y change as x change. Second is simplifying problems. Function help us simplify complicated math problems. It lets us to solve problems more clearly. Next is understanding change. Function help to describe how things change over time. Besides, we use function for forecasting. Functions are used to make prediction based on existing data or patterns.
So now I'm going to talk about the practical use of function. In the game Angry Birds, when you launch a bird from the slingshot, it follows a curved path as it travels through the air. This version is an example of projectile motion, and also this path is a parabola, and it can be represented by a quadratic function. And also others examples of quadratic functions in real life include firing an arrow, spraying water from a hose, and shooting a basketball. In Angry Birds, understanding this function can help players predict where to aim. Quadratic functions shape the path of the bird. So, if you understand this, you can better control its motion to hit targets effectively. The dotted line in the image shows the trajectory of the bird, which is the parabolic curve. According to the equation, y represents the height of the bird at any given point, while x represents the horizontal distance from the starting point. Coefficient A controls the curve's opening direction and width. It affects how wide or narrow the parabola is, as well as its direction, which is opening up or down. For the bird's path, A is negative, making the parabola open downward since gravity pulls the bird back down after it reaches the peak. If A is larger, the curve would be narrower, indicating a steeper trajectory. Coefficient B determines the initial angle and directions of the launch. If you pull the slingshot back at a steep angle, B will be larger, giving the parabola a sharper or steeper top. If you pull it at a lower angle, B will be smaller, making the trajectory lower and flatter. In this image, the angle is moderate, so B is not extremely large or small. It is enough to give a bird a reasonable height without going straight up. Coefficient C represents the starting height of the bird when it leaves the slingshot. Next, identifying points on the parabola. Launch point is also known as initial point, which is 0 in this graph. Our vertex is the highest point. It is the peak of the bird's flight path when it reaches its maximum height before starting to descend. Ending point is the point where the bird hits the ground. At this point, the height returns to ground level, similar to the initial point. It means the parabolic path is completed.
Next is using the function to predict motion. If we know the value of A, B, and C as explained previously, we can predict the bird's trajectory. For example,
as you can see in this video, if we want the bird to hit a specific point like the first target point and second target point, we can use quadratic functions to understand how change to the angle and strain affect the parabolic path to aim accurately.
Okay, so next I will be explaining the example in transformation of graph. Suppose the bird's path follows the function of y equals negative 0.03 x squared plus 0.98 x, where the negative coefficient of x squared indicates the parabola opens downwards. Since it has a negative, so the bird eventually falls. And the specific values of the coefficient affects the height and the distance of the trajectory. A controls the direction, whether it is up or down, and the width of the parabola. B affects the horizontal position of the vertex, which is the highest point, and it will shift it left or right. C affects the vertical position, which will shift the whole graph up or down. But for this graph, it doesn't have a C because the initial position starts from 0.
In conclusion, functions are fundamental in mathematics which describe the relationship between variables. Through this video, the game Angry Bird explains how functions help us predict the movement and outcome based on initial conditions. Besides, mastering functions not only enhances our mathematics skills but also become an essential tool in our daily life such as games and sports. This is our reference list. Thank you.